Good morning. With group number 9 from the robot modeling class, we're going to talk to you about some welding robots. Today with me is Valeria Proano and Ruocco. Welding robots is a programmable automated mechanism that performs a welding process while it also handles the part. This type of robots entered the U.S. industry in the 1960s, but they start welding until the 1980s. They're commonly used for resistant spot and arc welding. Resistant spot welding is a process where the metal surfaces are joined by the heat obtained from the resistant to an electric current flow. It uses a shaped copper alloy electrode to apply pressure and convey the electrical current through the workpiece. Now to talk about some of the arc welding is Valeria.
So arc welding uses power supply to create an electric arc. The way this works is that it melts the welding electrode and it burns a flux coating and melts it all together to the base metal. It uses AC or DC power. Now I'm going to show you a picture of arc welding. This is actually the setup. You have the base here, which is the earth or ground, according to positive or negative, according to your application. You can see here the welding rod, and this is the flux coating that it has on it. So the flux, what happens is when it heats up, it actually connects the welding rod to the base. Now I'm going to give you a robot in the industry. This is a video found from Art World. This video shows the actual the robot working on a piece. This is arc welding as well. And here you can see how you have a part which rotates, and then you have inline robots that perform the welding. Now Joseph is going to talk to you about welding robots, their advantages and disadvantages.
Okay, so welding robots. Now, to talk about the advantages. Basically, welding robots are made for linear motion, so they allow motion in the X, Y, and Z components, as well as rotation of the wrist. Welding robots are reliable, accurate, and allow for repeatability. So basically, they can do a task over and over again. Also, they reduce labor time. Now for the disadvantages. Welding robots require maintenance of components. So basically, what you're going to be doing is you're going to be replacing parts, and that's going to increase your cost. Also, they need to be programmed, so they need codes. These codes increase cost, and they also take a lot of time. After these robots are being used over and over again, they're going to need to be recalibrated and reprogrammed. So that's going to be used only after constant operation. Now for the history and the competition. Basically, in 1979, a company called Nachi decided to develop the first generation of spot welding robots. Later on in that year, a company called OTC introduced the first generation of arc welding robots. In 1988, Motoman introduced the control system called the ERC, and basically it allowed for 12-axis motion. Currently, over 27 axes of motion are being used. In 2003, the AX series by OTC was introduced, and basically it allowed for an advanced control capabilities of the arc welding. Now we're going to talk about the design process we did in this project.
To talk about the robot design process. The robot design process basically, we identify our problem statement. We began talking about the conceptual design that we're going to use. We're going to use a 3-degree of freedom planar welding robot, and we actually have to select the design. We select to do a PRR robot, and the application for our system is going to be a triangular bracket for a beam reinforcement.
Okay, so now for the process. Basically, the first thing we did was define the type of robot that we wanted to use. So we decided to go with a PRR, which is a prismatic followed by 2 revolutes. After that, we decided we fixed the XH and the YH, which are the corners of our triangle. Now, to follow this path, we had to define some link lengths and fix one of these links. After that, we decided to use the inverse kinematic equations to find theta 2 and theta 3. Now, these angles are the angles of the arm number 2 and arm number 3. And in our calculations, theta 1 was the angle was 0. Now, after this, we decided to use a step to find each single point on the trace path that we wanted our welding machine to follow. After this, we animated our welding robot using SolidWorks. Now, here is the trace path. Now, basically, each single dot represents a point of motion that our welding robot is going to be doing. Now, for the diagonal parts of that triangle, we decided to go with a step of 0.05 inches to increase the precision. Now, this process is being done by interpolating. So, as many points we have, the more precise the robot is going to be. And for the horizontal part, we decided to go with a 0.01 inches of step.
Now, I'm going to talk to you about the analysis of this problem. The way we approached this problem was inverse kinematics for the diagonal paths, which are diagonal 1 and diagonal 2, as you saw in the trace path. The way we did this, we found the main equations for our angle. We have the end effectors, and here are the input dimensions. We set for the 2 diagonals a specific S1, which is our first link, and we set A2, A3 to 10 and 6, and our theta 1 for everything is 0. Here you can see the derivation to find the absolute angles. So you have the x-axis is pretty much the derivation of the 2 main equations, and we end up with a theta 3 and theta 2, which are 2 closures. So you have, once you have the 2 closures, you have to actually define which closure actually gives you the way you want your robot to move. Now, for the horizontal path, we're going to see we have, first we found the 2 angles at the end of position 2. Then we fixed those 2 angles, theta 2 and theta 3, and we set y as to be 5, which is constant, and x will change from 5 to 0 with 0.1 step. Then finally we set S1 as x, and pretty much that's our changing prismatic link, moving from the right to the left. This is the animation of our robot.
As you guys just saw, our robot actually did the triangular shape that Joseph described earlier. As he said, also we have the bottom arm is going to be prismatic, and the other 2 are going to revolve around trying to follow the path of the triangular shape. Now, to conclude, we effectively survey the field in order to get the information that we need in order to find the right function for our robot. We also saw different applications that the robot were able to do, and the different companies that do these robots in order for us to gain all the data that it was needed for this project.
Also, in this project, we developed and followed a robot design process as we spoke before, and we achieved a specific and effective motion of the robot.
Finally, we approached this with the problem-solving techniques. You actually had different ways you can actually approach those end effector motions, and we also learned how to animate that robot in the CAD software. So through with this, we were able to find the animation and actually prove that our angles and all our motion was actually accurate.